So evaluation is one of the internal assessment criteria. It's really probably the last one that you'll tackle. And in my opinion, it is the most challenging one to earn high marks on, both because it's last, so people tend to sort of run out of steam or space and word count when they're writing it, but also just because it's quite difficult. So we're going to look at strands 1 and 2 together and strands 3 and 4 together. Strand 1, a detailed conclusion is described and justified, which is entirely relevant to the research question and fully supported by the data presented. So it does overlap a fair bit with the process data is correctly interpreted so that a completely valid and detailed conclusion to the research question can be deduced, which is strand 4 of analysis. And sometimes it's a bit tricky even for me to pick out which comments you make I should mark in strand 4 of analysis and which is in strand 1 of evaluation. I guess the difference for me is the interpretation is just directly describing what you're seeing in the data, whereas the evaluation is connecting it back to the research question. So to me, I focus on here that you should be answer the research question. So if your question was, how will X affect Y, you better come up with an answer of, based on your data, how does X affect Y? So it should always be based on the data. Don't be afraid to give a limited conclusion. Make a statement about confidence here. I think they really respect that when you can say, my data suggests that X affects Y in a linear way, but because the R squared value is quite low, I'm not particularly confident in this. I'm also not confident because I only have 2 trials, and so there's a fair bit of variation, yada, yada, yada. So answer the research question, based on whatever it is. So how does X affect Y, or how do these things compare? Make sure you actually come up with an answer to that, or else it's not going to be entirely relevant to the research question, and you're going to get dinged here in evaluation. Describe it fully. So make sure you're fully describing what your conclusion is, and try to justify it. When they say justified, you're going to back it up with reference to the data. So you don't have to talk about every data point, but you might talk about important data points that are outliers. You might talk about the slope value of a trend line, or the general type of trend line that you established in the equation that you came up with. Things like that. You might talk about R squared values. You might talk about uncertainty values. So you're going to justify it by describing the data in detail, and you're going to actually answer the research question in strand 1. Strand 2, a conclusion is correctly described and justified through relevant comparison to the accepted scientific context. So notice that the first part of each strand is really exactly the same. The first part is that you're backing it up based on your data. So it's fully supported by the data. And in this one, it's relevant comparison to the accepted scientific context. So ideally, what this means is that you would compare your results to any literature values that are available, and that's how you're comparing it to the accepted scientific context. Now, your results don't have to match the scientific context or the concepts or the literature values. They are what they are, and that's fine. You have to compare them honestly to the lit values. And so if they really don't match, that can be support that you're really not confident, in your results. However, if they do match, then it can be a way that you justify and support the fact that your results, that you're confident in your results and you're confident in your answer to the research question. So comparing your results to any literature values that you could find, whether they're in the data booklet or from an online source, that's great, but cite them if you do find them. If you don't have literature values, which oftentimes you don't, then compare to the correct scientific explanations or concepts. And I find this is the part that people have done the worst on of all the strands in the IA. This is something that you do in the exploration in your background information. You've explained the concepts, and now you're going to basically do that again. So you're going to revisit a lot of the background info that you looked up at first and possibly add to it some new ideas. Maybe some new things came to light as you did the investigation, you look at your data. But look at the correct scientific concepts and explanations in order to try to explain what the results are or what they should be. This is where you're trying to explain the accepted scientific context and comparing it to your results, which can lead to comments about confidence in your conclusion and your answer to the research question. If we move on to strands 3 and 4, they tie in quite well together: strengths and weaknesses, improvements and extensions. So in the first part, it's important to note that they do expect you to talk about strengths. So things that went well, such as perhaps you collected a lot of trials, so you did 5 or 6 repeats of each value. That would be a strength. Or you tested a wide range of independent variables. That could be a strength. You did a nice job controlling certain control variables. Those are all things you can point out. To me, it's a little less important than the weaknesses, but it's on here, so you should point out strengths to make sure you get credit for it. So check number 1, let's point out strengths. But then weaknesses. Weaknesses have some different categories. You've got practical considerations, such as, my thermometer wasn't precise enough, or it was really hard to tell when the color change happened, so I think I was overshooting my volumes. Practical considerations are important. And anytime you bring up a sort of method or a piece of equipment, you should try to explain, how did this affect my data, my results, my readings, things like that. Did it make the values higher than what they should have been, lower than they should have been? Did it make them vary? So thinking about the idea of systematic versus random error here, but actually thinking about how did they affect my data. I think that's something that people often overlook. But in addition to practical considerations, you can't get really above 1-2 if you only talk about practical investigations. The student, if I look up here at the strand, if you look at 1-2, it's restricted to an account of practical or procedural issues faced. So if you only talk about your equipment and your method, you can't really get above a 1-2. Both 3, 4, and 5, 6 have some mention of methodological issues, which, as I've read further, have to do with the overall design of the IA and limitations in your data. So what does this mean? Did you test enough independent variable values to feel like you have enough data to go on to make a valid conclusion? Did you do enough repeated trials? Were there factors beyond your control? Like especially with biological specimens, if you're testing things about fruits or foods and things like that, there's so many different things that could go into those different fruits. You have no real way of knowing if they were all grown in the same conditions, in the same place, things like that. So there's going to be a lot of variation. So this last one has to mainly do with biological samples and just natural variation that you can't possibly control. So all these things that could limit how confident you are in your conclusion and limit the validity of your results. For any of these weaknesses, then you need to suggest an improvement. Improvements need to be specific and detailed, and you should explain their impact. How will they affect the quality of the IA, of the investigation? The student has discussed realistic and relevant suggestions for improvements and extension of the investigation. So if I talk about a piece of equipment that was weak, then I talk about the new piece of equipment specifically that I would use. If I had a method that was bad, what's the new method step that I would take? Or what's an alternate method I would try? If I've got limited IV values, then what are the additional IV values to test? Don't just say, I would test more values. Suggest which ones you would test. The number of trials, how you would increase that to lower random error. And variation stuff may be beyond your control, but you can try to limit variation. In terms of where do you look for weaknesses, a good place to look is your control variables. It's always important to think about how were they not actually controlled. And with that, you've written an evaluation. The important thing is lots of good thoughts and details and thoroughness.